Have you ever pondered the existence of water on Mars? In this video, we're uncovering a game-changing discovery on the Red Planet, thanks to the European Space Agency's Mars Express orbiter. This revelation challenges what we thought we knew about Mars and gives us fresh insights into its climate history. Stick around for a quick dive into this cosmic mystery that could reshape our understanding of this planet. The Mars Express orbiter, a probe operated by the European Space Agency known as ESA, has recently identified a significant reservoir of water on Mars. The detected water volume is substantial, enough to potentially cover the Martian surface with an ocean measuring between 4.9 and 8.9 feet in depth. This water is found in the form of icy deposits beneath Mars's equatorial region and is concealed by layers of dust. The discovery was facilitated by the long-serving Mars Express mission, a spacecraft that has been conducting scientific operations around Mars for 2 decades. While previous indications of ice near the red planet's equator existed, this recent finding represents the largest quantity of water ice identified in this region to date. Thomas Waters, the lead researcher from the Smithsonian Institution in the United States, emphasized the excitement surrounding the radar signals, noting their similarity to signals from Mars's polar caps, which are known for their high ice content. The subterranean deposits, extending 2.3 miles below the Martian surface, are covered by a layer of solidified ash and dry dust measuring hundreds of meters in thickness. It is important to note that the ice is not in a pure state, but is significantly mixed with dust. While the equatorial location of this discovery could potentially be advantageous for future crewed missions, the depth at which the water ice is buried poses challenges for accessibility. Approximately 15 years ago, Mars Express identified deposits beneath the Medusae-Fossae Formation, or EMFF, a geological structure spanning 3,106 miles and situated near the boundary between Mars's northern highlands and southern lowlands. The MFF is believed to have formed from lava flows and volcanic ash approximately 3 billion years ago during a period of Martian volcanic activity. Despite its current status as a source of substantial dust on Mars, the recent observations from the subsurface radar MARSIS on Mars Express have clarified that the deposits are not mere dust but exhibit characteristics consistent with low density and transparent water ice. This discovery prompts inquiries into the origin of water ice at the equator. Previous instances of subsurface ice on Mars include NASA's Phoenix mission, uncovering ice near the polar landing site in 2008, and Mars Express detecting water ice in mid-latitudes. More recently, ESA's Trace Gas Orbiter identified hydrogen from water ice beneath the surface of Candor Chaos, a segment of the vast rip in Mars' surface known as Valles Marineris. Additionally, remnants of ancient glaciers, referred to as relic glaciers, have been observed in eastern Noctis Labyrinthus, just 7.3 degrees south of the equator. The presence of subsurface water ice at low and equatorial latitudes suggests significant climatic variations in Mars's distant past. Colin Wilson, an ESA project scientist for Mars Express and the Trace Gas Orbiter, acknowledges that this latest analysis challenges current understanding and raises questions about the duration and conditions surrounding the formation of these ice deposits. One proposed explanation for the existence of equatorial water ice involves Mars's axial tilt variability over its history. Mars's axial tilt has likely experienced chaotic variations, with the current tilt at 25 degrees compared to Earth's 23 degrees. During periods of high obliquity, where the poles point closer to the sun than the equator, substantial amounts of water ice could have formed on the equatorial surface. Subsequent burial by ash and dust falls would have preserved the ice to the present day. This changing obliquity theory may also contribute to the understanding of features discovered by the Chinese Zhurong rover and the existence of gullies formed by liquid water in unexpected locations. The detailed findings of this discovery are published in a paper in Geophysical Research Letters, providing valuable insights into the Martian geological history and climate. As we wrap up our dive into the incredible find of water on the red planet, feel free to drop your thoughts and questions in the comments below. Due to this discovery, do you believe life existed on Mars? If you found this video informative, please give it a thumbs up and subscribe to our channel for more science and space content.